Hello dear students. In the previous class under gravitation we have already studied what is gravitational force of attraction, what is universal of gravitation, what is gravitational constant, its unit, free fall, acceleration due to gravity and so on, right? And in today's class we are going to learn the further topics of the same lesson. That is, first point is today's class, that is variation of G on the earth. How does the acceleration due to gravity varies on the earth? Let us take the shape of the earth. As you know already, earth is not a complete sphere. Its shape is geoid. Geoid means it is flattened at the poles and bulged at the equator. Means this diameter, equatorial diameter, is greater than this polar diameter. Okay, it is shorter. This is longer, this radius. So we know this one. If you take that acceleration due to gravity, this acceleration, it is calculated based on the gravitational force of attraction acting on that object, that is F is equal to G into M divided by D square. Here D will be nothing but radius of the earth, that is R square, right? Now coming to the topic here, radius as it is greater here, acceleration it is different. If you take the same radius at the poles, it will be shorter. Here distance reduces, force increases. Here distance increases, force reduces. Means what? Here acceleration due to gravity, it will be more at the poles, less at the equators, right? Because of that we can say G is not constant everywhere on the earth. It is different at the polar region and it is different at the equator. Okay, equator, this we can say. Now coming to the next point, that is mass and weight. How do they vary then? Mass and weight. What is mass? Mass is nothing but it is the quantity of matter. Very simple. The quantity of matter we can consider as mass. Mass, as we already studied in the second lesson of this physics of class 9th, that is laws of Newton's laws of motion and force, we have studied there. Under that it is defined. What is that? Mass is nothing but it is the measure of inertia, we can say there. As the mass increases, inertia of the body also increases. Inertia of the body entirely depends on mass of the object, right? Greater the mass, greater the inertia. Lower the mass, lower will be the inertia. This we already studied. Now this mass, if you consider here, mass is nothing but the quantity of matter. So if you write the differences here, mass, one side weight. Mass is the quantity of matter, we can say. It is the quantity of matter contained in an object, we can say. Quantity of matter. Whereas what is weight? Weight is nothing but if we are standing on the earth, we are having some weight. Why do we get that weight? Just because of the gravitational force of the attraction. With that force it is pulling us towards itself, right? That force we are measuring in terms of weight. Then weight is nothing but it is the gravitational force of attraction. And force will be measured, F is equal to mass into acceleration, as you know. But here, since this acceleration is given by the gravitational force itself, so because of this changes to mass into acceleration due to gravity. Because of that we are getting weight. Now this force is nothing but weight, we can say. See, weight is nothing but that is the force. That force is given by mass into acceleration due to gravity. Now you see, this acceleration due to gravity, it is constant. It is not varying from one place to another place. Throughout the earth we are considering it to be constant there. And since this acceleration due to gravity is remaining constant, now the weight or this force acting on our body, which is pulling towards the earth, that depends entirely on the mass of the object or body there. Means acceleration due to gravity is same. We are considering it to be same throughout the earth there actually. But here mass, this weight depends on mass now. Means what? Weight can be measured in terms of mass now. Just we can consider weight can be measured as mass. Greater the mass, greater the weight we can say. So what we can say is weight is nothing but it is the force with which it is the force with which earth attracts us, attracts the objects. Okay, now first point over. Second point, coming to second point, quantity of matter you take anywhere on the earth, it remains same. You just take it out of the earth, it remains same. In the universe, wherever you take the object, its quantity of matter always remains same, it does not change at all. Okay, so we can say here quantity of matter is called mass, and mass remains same. Mass remains the same everywhere on the universe, in the universe, okay? On the earth or in the universe, right? Whereas the weight changes from one planet to another, because if you consider on the earth weight of the object is different. If you take it on the moon, it will be different. If you take it on another planet, then also it goes on varying there. 5. Weight is nothing but it is the force with which the objects are attracted towards that planet, right? If, for example, if you consider mass of the moon, mass of the earth is greater than the mass of the moon. So the force with which it is attracting the objects will be greater, that is by the earth. What type of force this moon exerts on the objects, that will be lower than the earth's. Means because mass of the moon is less, gravitational force of the moon will also be less. Mass of the earth is greater, so gravitational pull which is acting on that objects will also be more here. So because of that, we can say it changes from planet to planet weight, whereas mass remains everywhere same. Then what are the SI units of these? SI unit of mass is, that is kg. Mass we are measuring in terms of kg, that is kilograms. Whereas the SI unit of weight is measured in terms of force. Now force can be measured mass into acceleration due to gravity, right? Acceleration due to gravity's unit will be just meter per second square. Mass means kg. Kg meter per second square we can say. Now let the mass of the moon be m, and mass of moon be m, small m, and its radius be rm. Okay, as we know already. Let us according to this one, let us apply the universal law of gravitation to this one moon. If any object is there of mass m on that, then what type of force is acting on that object, if you want to calculate, it can be written as F is equal to G into m, that is mass of the moon into mass of the object, that is product of the masses of the two objects, moon and object, divided by square of the distance, that is radius of the moon we can take. Let us call this as equation 1. And if you take the force acting on an object by the earth, if you take, uh, let that mass of the earth be me and mass of the object be m, same object, and radius of the earth be re. Now let us write the force acting on that object. F is equal to G into, according to universal law of gravitation, the product of the masses of the two objects, mass of the earth and mass of the object divided by distance. That is, distance means radius of the earth, that is square of the distance. We can take, this is equation 2. Now let us divide equation 1 by 2. Let us divide equation 1 by 2, and this force I can express, this is nothing but weight of the object on the moon, Wm, because this force is nothing but weight of that object on the moon, and this force is what? Weight of the object on the earth, right? If you divide this equation 1 by 2, what do we get here? Mass of the moon divided by weight on the moon divided by weight on the earth will be equal to, if you divide both the equations, this g gets cancelled, and this mass of the object remains, means that also gets cancelled. What remains? Mass on the mass of the moon divided by radius square of the distance, that is radius square of the moon. Next again, this mass of the earth divided by radius of the earth, that is square. Like this we get. If you simplify this further, we get m upon m means radius of the moon. This is mass of the moon. Okay. If you simplify this, this goes to numerator, that is radius square of the radius of the earth divided by mass of the earth. Now if you substitute the value of mass of the moon and radius of the earth, mass of the earth and radius of the moon, if you substitute all these values, then we get the ratio of weight on the moon, weight of the object on the moon and weight of the object on the earth will be equal to 0.165. After substituting these values, we get 0.165, which will be approximately equal to 1/6. Just a simplification it is. If you substitute the values, it is already given in the table in the textbook. Just substituting and finding the value, that you will get 0.165, which is approximately equal to 1/6. Now we can say that Wm is equal to 1/6 into We. Means what? Weight of an object on the moon will be equal to 1/6 its weight on the earth. Means you have to multiply 1/6 with weight of the object on the earth, if you multiply. Otherwise, if you take object's weight and divide it by 6, then you will get its weight on the moon. This is what the relation between weight of the object on the moon and weight of the object on the earth. If you follow this, then the further calculations can be done easily. Okay. So we'll stop here, and in the next class we'll go ahead with the remaining topics. Okay, thank you.